Good morning! I hope you all are doing well. These videos today that I'm creating are for the Chapter 8 review to get you prepared for the Chapter 8 exam. Now the Chapter 8 exam this year has 18 questions and it covers every single factoring experience that you could tackle, including GCF, which means greatest common factor. Also on this test is going to be DOPS, which is difference of perfect squares. I'm also going to cover PTS, which is perfect square trinomials, or PST, perfect square trinomials. I'm also going to tackle two other types of trinomials, one where the front number is an invisible 1, and one where the front number is a number that is greater than 1, but not necessarily a perfect square. And then last but not least, we have 4-term polynomials. So we have a wide variety of strategies. I'll be testing you out on 1, 2, 3, 4, 5, I think 6 strategies. And it's 18 questions, and each question's 5 points. And if you're taking versions A and B, which is the test where you're here on the day of the actual exam, not version C, which is the makeup test, there's an extra credit problem on the back that you're welcome to tackle for an additional 5 points. So let's get started. I think the hardest thing for kids to do was like, well, what strategy do I use? Okay. And for me, I have like a 4-step plan, and I just follow these 4 steps, and I know how to tackle anything that's coming my way. So I'm going to show you that 4-step plan. I think I'm going to turn the projector on so that we can just see the board kind of like nice and plain. Okay, so the first thing that we always look for, no matter what, and we check all math problems for this, aka any polynomial that could come our way, we're checking all of them for a GCF. That's known as the greatest common factor. So all polynomials get checked for a GCF. And GCF again stands for greatest common factor. So step number 1, first thing you do when you have doubt is check it for a GCF. What the heck do you mean by GCF, Mrs. Miller? A GCF is kind of an example that I could give, something like this. Okay? We're looking for a number, letter, both, that we could equally take out of this question. Let me make it a little bit bigger so y'all can see it at home. Okay? So this is definitely, to me, a GCF question. Why, instantly I see that I could take a number out of both. The greatest, it would be 2 in this case. I also see that I could take a letter out, and that would be a single x. So the GCF, the greatest thing that they both have that I can remove is a 2x. What's left over? Well, 2 divided by 2, invisible 1. X cubed, take away an x. So if you had 3 x's and you took away 1 x, you're left with 2 x's. Drop that negative. 4 divided by 2 is 2, and x, take away an x, you ain't got no x's. Final answer. So that would be a good example of a GCF question. And anything coming your way, you're going to check it for GCF. So that's my first strategy. Now, let's say you've checked it for a GCF and it doesn't have one. Well, you're going to go right to the second step. Now, the second step is only for binomials. A binomial is a 2-piece math problem. Okay? A binomial is a 2-piece math problem. Like a bicycle has 2 wheels, a binomial is a math problem with 2 parts. Okay? So we're going to check that for a difference of perfect squares. So a difference of perfect squares. That's the next thing we look for. Now that's only for binomials. Only a binomial can be a difference of perfect squares. Let me give you an example. There's a beautiful example of a difference of perfect squares. Let's talk about why. First of all, I see a subtraction sign. That's another word for difference. A difference of perfect squares. So you have to have a subtraction sign in the middle. It must be a binomial. And the front and the back both need to be what we call perfect squares. Now, numbers on this poster right here are perfect square numbers. So 1, 4, 9, 16, 25, and so forth and so on. Anything with a little 2 above a variable is also considered a perfect square. So let's see if this matches the needed components of a difference of perfect squares. We have a difference, check. It's a binomial, check. I have a perfect square, 16 on the poster, yes. Is an x with a little 2 a square? Yes, that's actually, we call this an x square. So yes, this is a difference of perfect squares. Now how do we factor that? Well, like most things that we factor, we set up 2 sets of parentheses. We ask ourselves, what gives me the x squared in the front? That would be x times x. And what would give me the 16 in the back? That would be 4 times 4. Now we have to determine the signs. Are they going to be negative, negative? Are they going to be plus, plus? Or are they going to be mixed? That's what we have to figure out. In this case, a difference of perfect squares will always have mixed signs. The reason is when you go back and check the answer, the middles will cancel. That's what makes this a binomial versus a trinomial. So if I went to check my answer real quick, yes, I see those middles cancel. I have x squared minus 16. And by the way, why do the middles cancel? Right, because they're opposites, right? I have a positive 4x, take away a 4x. 4, take away 4, nothing left, my friends. So that's an example of a difference of perfect squares, and that's only for binomials. A trinomial is what's next. And we have 3 types of trinomials that we've learned about. So step 3 is only for trinomials. Like a tricycle has 3 parts, a trinomial has 3 parts as well. It's a 3-part math question. Now, what kind of trinomials can we have? Well, there's 3 types. We can have a basic trinomial where the front number is 1. We call that front number A. If the front value is an invisible 1, that's a basic trinomial. We also have perfect square trinomials. That's where the front and back are both a perfect square. And last but not least, we have trinomials where the A is bigger than 1. A value is bigger than 1. So it's a number like 2 or 3 or 7 or any number it could be in the front. So we're going to look at those when we look at our study guide pretty quickly, okay? So perfect square trinomials, basic trinomials, and trinomials, well, where the A is 1, and trinomials where the A value is greater than 1. All of them have something in common. They're 3 pieces long. The perfect square trinomial has a perfect square in the front and the back. So these numbers, you're going to have one of these in the front and the back, not the middle. Again, a basic trinomial is where the front number is going to be 1, and a trinomial that's kind of more spicy, you could say, is where that A value, that front number, is a number that's bigger than 1 and probably not a perfect square. Definitely, yeah, not a perfect square. Last one, we have step 4, okay? Step 4 is where we have the bigger problems. So maybe they're not 2 pieces long or 3 pieces long. Maybe they're 4 pieces long. Maybe they're 6 pieces long, right? We deal with this, the 4, okay? So 4-term polynomials, and we use a strategy called grouping. I think the easiest one to spot is this guy out of all of these, to be honest, because they're 4 pieces long, and it's the only one that's 4 pieces long. So I'm going to end this video here. This is just a quick synopsis of what we're looking for when we factor, and now I'm going to do Study Guide A. I've already sent you Study Guide A, the blank version, and the answer key, my personal answer key. So I'm going to go over that exact same study guide, 18 questions, covering all varieties, 1, 2, 3, 4, 5, and 6 varieties. Cool. Come back for video number 2. Have a great day.